Okay. Good afternoon, ladies and gentlemen, friends and colleagues. My name is Frederick Lee. I'm the Executive Director of the Center for Water Technology and Policy at the University of Hong Kong. Yeah. On behalf of the Water Center, I'd like to welcome all of you to attend today's interdisciplinary forum. Okay. The Center for Water Technology and Policy was established at Hong Kong U in 2018. We are an interfaculty collaboration between the Faculty of Engineering and the Faculty of Social Sciences. The Water Center aspires to become the focal point of research on salient water technology and policy issues in Hong Kong, and we have been conducting cutting-edge research on water technology policy interface issues from an interdisciplinary perspective, producing research findings that are relevant to policymakers. Now, before we proceed to the main presentations, I'd like to acknowledge the support of several parties. First, I would like to thank the Water Supplies Department of the Hong Kong Special Administrative Region Government for their support of the Water Center's research and knowledge exchange programs in the past 4 years. The Water Supply Department is a co-organizer of today's forum. Okay. Next, I'd like to thank Professor James Nickum for proposing the topic of smart water cities for today's forum. Professor Nickum is a friend for more than like 40 years, well, 30 years, okay, with me, yeah. And he is serving as one of the Water Center's 3 international advisors, and he has kindly introduced us to the 2 main speakers whom he has worked with through his professional connections with the International Water Resources Association, at which he has served as a vice president in the past. Okay, finally, I'd like to thank our 2 main speakers, Dr. Monica Quesada and Mr. Jang, as well as our 2 discussants, Professor James Nickum and Mr. Kwok Tai Chan, for sharing with us their expertise and knowledge on this most interesting topic of smart water cities. I'm going to ask my colleagues to play the recording of Professor Danny Lam's welcoming remarks. Now, Danny is traveling, so he cannot join us in person today. And that's the reason why we asked him to record, okay, his welcoming remarks.
Good afternoon, friends and colleagues. My name is Danny Lam. I'm a co-director of the Center for Water Technology and Policy. On behalf of the Water Center, I'd like to welcome you all to participate in this interdisciplinary forum. The Water Center is dedicated to promoting interdisciplinary collaboration, in particular between engineering and social sciences, in our research, teaching, and knowledge exchange activities. We believe that an interdisciplinary approach will help produce new insights into redefining the key challenges faced by decision makers in the urban water sector. Today's forum will focus on the topic of smart water cities. We are going to examine the question of how and to what extent the application of smart technologies, such as IoT, AI, and machine learning, could help address and resolve current and future challenges in managing our urban water systems to achieve long-term sustainability goals. As a research center dedicated to conducting cutting-edge research on urban water policy issues, we have just been awarded a grant of $4 million by the Hong Kong government to look into the question of how the application of smart technologies could help the government to advance its policy goals in water conservation. We therefore very much look forward to listening to the 2 main presentations on the subject matter of smart water cities, so that we could learn about the latest thinking on the issue from an international comparative perspective. On that note, I'd like to thank the 2 overseas speakers for their accepting our invitation to share their expertise with us. I'd also like to thank the 2 discussants for providing a rejoinder to the main presentations. Finally, I'd like to thank the Water Supplies Department, the co-organizer of the forum, for their long-standing support to the Water Center's research and knowledge exchange programs. May I wish the forum a great success.
Now, we're going to move on to the two main presentations. I'd like to introduce our first speaker, Dr. Monica Garcia Quesada. Dr. Quesada is a project officer with the International Water Resources Association, coordinating a 3-year project entitled Smart Water Cities. She holds a PhD degree in government and she has extensive research experience in comparative public policy and water regulation. Her work has been published in peer-reviewed journals, such as the Journal of Public Policy, the International Review of Administrative Sciences, and the International Journal of Public Administration, as well as in various chapters and edited books. Dr. Quesada speaks Spanish, English, and French. The topic of her presentation is Smart Water Cities. What are they? How to measure and compare them? So without further ado, may I introduce Dr. Quesada, please.
Thank you very much. Good morning, everybody from Brussels, and welcome to this session on smart water cities. First, I would like to thank Professor Lee, Frederick Lee, and Dr. Ada Chan for the invitation to participate in this forum, and also to all the attendees for attending this session. Indeed, my name is Monica Garcia Quesada, and I work as a project officer at the International Water Resources Association. And at IWRA, I coordinate a project entitled Smart Water Cities, which, as Frederick mentioned, is undertaken in collaboration with K-Water and the Asia Water Council. This project has served to examine the concept of smart water cities and the use of smart water technologies in urban contexts around the world. And I would like to tell you about it in the next few minutes. I'm going to share my screen now. Right. Can you see well? Yeah. In my presentation, I would like to discuss these 2 points. First, we will start by defining the concept of a smart water city. This entails a discussion of the principal features that define a smart water city. We are going to see if there is a single approach or different approaches to the concept and what these differences mean. Second, we will discuss about the instruments that help us to examine and compare smart water cities. This is going to help us to identify the challenges for the development and also the areas where more attention is needed. If there is one single message to take away from this talk, is the need to develop an instrument to evaluate smart water cities. And that instrument needs to be comprehensive enough to portray smart water cities adequately. First of all, we need to establish that there is no an agreed definition of what the smart water city is. The following is a definition that the Smart Water Cities project gave to the term. This is, as you see, a definition in 2 sentences. The first one is perhaps the more promotional definition that says a smart water city is a sustainable city with intelligent water management for all. The second, but I am more interested in the second part of the definition. What it says is that smart water city improves the quality of life of citizens by solving existing urban water problems based on various technologies and ICTs throughout the urban water cycle. There are various elements worth highlighting here, but I wanted to focus on one area where, where I think this definition is particularly relevant, which is the reference to the urban water cycle. Oops. To come up with the definition, we decided to examine the functions of water that water fulfills in a city. We looked at the urban water cycle and at the different roles of water and how technology can intervene at each stage. What we wanted to avoid is to look exclusively to the role of technologies in the provision of drinking water and sanitation, which is the conventional approach to urban water management. What we wanted to do is to look beyond this. And at the bottom of the graph, we have indicated the different interventions that humans can have at different stages of the urban water cycle. And you can see there monitoring rain, urban water management, low impact development, water quality. So throughout the circle. The idea when defining a smart water city is that smart water city includes not only solutions for conventional water management in areas such as drainage or water treatment or wastewater treatment, but it also improves urban water management throughout the restoration of the urban water cycle, the uses of the waterfront and the management and the intelligent water management. Here, waterfront usage refers to urban planning measures that integrate the waterfront in the city, so residents can enjoy a safe access to water and water activities for leisure or well-being. Water cycle restoration refers to the activities that facilitate the rehabilitation and the maintenance of the urban water cycle and the better use of resources, things like water reuse, water storage system, development of permeable soils, etc. Intelligent water management refers to the use of information and communication technologies throughout the urban water cycle in things like the development of software for graphic data representation or data management and storage or communication with users, etc. The possibilities for smart interventions in a smart water city go therefore beyond the conventional sectors. I am going to leave the debate here on the concept of smart water city, although there are a few things that will come back later in the presentation. Once we have established what a smart water city is, we can ask the question of whether a smart water city exists around the world. And to find out, our project examined different examples of the use of smart water technologies in urban areas. What we did was to send out a call for case studies where we invited researchers and water professionals to let us know about the use of technology in water services provision and water management in different cities around the world. We received several cases and we chose 9 of them. And one of them, as you can see, is Hong Kong. I am going to here to present some of the features of the cases that we received. Looking at this table, we can see various things. What we see is that the city cases come from different countries in different regions of the world. So we find efforts to introduce ICTs in cities of all continents. We can see also that the cities implementing smart water solutions are very diverse. We see them here classified according to population, to type of city, so old or new city, and economic development. In addition, we can see that the solutions that they propose have concerned different types of challenges, things like water pollution, water scarcity, aging water infrastructure. Furthermore, if you see the report, which is available for free in our website, you can see that the solutions that the city present are very different. We have things like use of smart meters, membranes to filter water for drinking purposes, mechanisms to use to reuse wastewater, or systems to monitor flood risks. What we found interesting is that not all solutions were high-tech solutions. So cities did not necessarily implement the latest technology. The authors consider and argue that these solutions were smart because they served the needs of their city. And this is something that we have kept in our definition of smart water city. Let's look briefly at some of the findings of two examples, two case studies. In this table, I'm presenting the cases of Ciudad Juárez in Mexico and the case of Heredia in Costa Rica. Ciudad Juárez and Heredia faced two different water challenges. It was aging infrastructure and leakage, and for the case of Ciudad Juárez, and the insufficient water quality for drinking in the case of Costa Rica. The solutions that the city proposed were both conventional and smart. In the case of Ciudad Juárez, the city initiated a process of renewal of the network to introduce new pipes to avoid the leakage. And they did also include some smart technology that helped to identify where the renewal was most necessary. And it consisted, as you see, in the smart meters, in pressure control valves, in an advanced metering infrastructure, and a cloud software platform. Similarly, in Heredia in Costa Rica, the conventional technology was the introduction of a drinking treatment plant. But smart technology was introduced in one of the phases of the water treatment. And they also implement a digital system to gather information on water quality. I think what is interesting here is that in both cases, reforms were necessary for the management of the resource in urban, in water governance. Ciudad Juárez had to agree on a new master plan for the whole city, and agree also on the development of instruments to raise the financial resources necessary for the introduction of the new measures. This involved the modification of the water tariff system. What they did was to identify first the heavy water consumers, and started by charging them first, sparing the more vulnerable consumers. They argued that not doing so would have made the measures quickly unpopular and difficult to implement. They also referred to the need to develop technical capacity in human resources. They argued that those that operate the technology need support. In the case of Ciudad Juárez, they created an interdepartmental body of professionals. In the case of Heredia, they had to organize continuous training courses. What these examples showed is that the technical factors and the governance and organizational factors go hand in hand. There are other cases in the report. My colleague Sumpil Jang is going to refer to one of them, the Busan Eco Delta Smart City in the Republic of Korea. But from the cases that we analyzed, we identify two main approaches. First of all, some countries have adopted a comprehensive approach to developing smart water cities. And this involves designing a smart water city from scratch, from planning to implementation. This has longer time frames, more ambition, and more demands. This approach requires a large collective effort, which in not all cases is successful. A case study in the report showed some of the failure that these large projects faced in India, in the city of Mumbai. In many other cases, the cities have adopted a more piecemeal, incremental approach to smart water cities. The measures under this approach are frequently restricted to an area of the city, and they involve the renewal or the retrofitting of existing infrastructure. It has shorter timeframes, so the result, the smart city is the result of a series of different independent activities. This is less ambitious and more flexible. The main problem that it faces is that existing infrastructure settings may not be that smart, and therefore the result of the technologies might be limited. Given that there is such variation, we asked the question, how can we compare different cases? For this, I'd like to move now to the second part of the presentation, namely the discussion of how we can measure whether a city is a smart city or not. For this, in our project, we wanted first to learn from experience. And what we did was to select a series of standards and certification schemes that have been developed and employed by international organizations and not-for-profit organizations to analyze smartness and the sustainability of cities. In total, we examined 8 standards, the ones that you see on the slide. But here I'm going to focus to refer to 2 of them: the OECD Smart Cities Measurement Framework and the City Blueprint Approach. This is the OECD Smart Cities Measurement Framework. Evaluates and compares cities' policies to introduce digitalization in local services. The framework has 3 categories. First of all, you see in the circle in the middle is the first pillar, is called the digitalization pillar, which measures digital innovation at the city level by the use of ICTs. The second pillar is called engagement, which measures the involvement of city stakeholders in building a smart city. And third, the third pillar, smart city performance, measures 4 elements of urban life: well-being, inclusion, sustainability, and resilience. The water sector is one of the sectors examined in the digitalization category in the first pillar. The idea here that what this standard does is to examine to what extent the water sector has introduced ICTs. The Blue City approach is an assessment tool developed to evaluate the sustainability of urban water resources. It examines 3 categories. First of all, it examines the trends and pressure framework. It examines the urban water challenges that cities face, and it has 3 subcategories. It looks at social pressures, environmental pressures, and financial pressures. The second is called the City Blueprint Framework, and assesses how effectively a city manages the urban water cycle. Thirdly, the governance category, governance capacity framework, they call it, examines how cities manage their water resources. If we compare them briefly, we can see the following. The OECD instrument examines the degree of digitalization and digital innovation in a city. The main strength of the standard is that it has developed smart indicators, and it measures what impacts digitalization has on the quality of life and well-being of citizens. However, it does not measure the water sector fully or the urban water cycle in depth, but it only focuses on the provision of water services. So we do not know very well to what extent other ICTs, how other ICTs have been implemented in cities in other sectors. As for the City Blueprint approach, which is more complex, it looks at the sustainability and the management of urban waters. It is interesting in that it measures the challenges of cities and therefore the starting point of different cities. It can be therefore a good instrument to measure progress. However, it includes only a few instruments on digitalization, and it does not include all stages of the urban cycle. So it misses some key steps. Just wanted to go briefly go through some of the lessons that we learned by examining the city cases and also by examining 8 standards and certification schemes. What we learned is that all references to smart water cities put the focus on sustainability. We no longer see smart cities only regarding the implementation of ICT. Smart cities look at the environmental impact of the activities and the services that they provide. Secondly, smart city uses both conventional and information and communication technologies to improve quality of life. So the focus is not so much on identifying whether a city implements the latest technology, but whether it is, if it is capable of meeting the needs of the population with the technologies that the city employs. Thirdly, the standards have put the accent on governance. Smart cities are not only about ICTs, but good governance and of urban water resources is necessary for smart cities. However, as no current standard or certification scheme for smart water city exists, we have identified also certain deficits. Indicators, mainly the focus of indicators and this standard has been on access to drinking water and sanitation. So indicators considering the different functions of water in the system in the city are very scarce. Also, we find that indicators measuring the implementation of smart technologies are also scarce. So we know little about how far cities have gone in the adoption of ICTs. And we have little evidence of the impact of ICT in the water system. Whereas there is a constatation that of the importance of governance, there are very few analyses, perhaps with the exception of the city blueprint approach, that looks at different at the importance of governance and with extensive performance indicators. And also, we find that standards have paid little attention to changing circumstances in cities, particularly linked to urbanization and climate change. So our work at IWA has aimed to develop such a comprehensive standard. And this standard will measure cities in 3 main areas referred to as pillars. We have our standard will have a governance pillar, a technical, and a prospective pillar. We are currently defining the KPIs for each pillar, establishing the numbers and the content of each KPI. The governance pillar here is concerned with the institutional and regulatory setup for the management of urban water system. The technical pillar examines the use of conventional water technology and ICTs at the different stages of the urban water cycle. And the prospective pillar assesses future trends and how they can impact water system. We will publish the final version of the standard this year, so stay tuned. Just very briefly, I wanted to show you some of the categories and the subcategories of the governance and the technical pillar. In the governance pillar, follows some of the work of the OECD on principles of water governance. The pillar accounts for elements such as effectiveness, efficiency, and trust and engagement in the management of water resources at the local level. And then the categories, these 3 categories is broken down into several subcategories and then into KPIs. The technical pillar is divided into 3 categories corresponding to the urban water cycle, the water supply and treatment, and the water safety. And then again, each of these categories is divided into different subcategories that look at the whole urban water cycle. I am reaching the end. I just wanted to recap a little bit. first of all, what I wanted the main messages of my presentation is that, first of all, the concept of a smart water city has been of great topicality. Although we have also seen that the concept remains vague, in particular as it tends to refer only to water services provision and not other areas of the urban water cycle. Secondly, we have also seen that there is an enormous variation in smart water solutions. So we have difficulties to compare and learn from these experiences. And thirdly, I have also argued that developing a comprehensive smart water city standard can be the way forward, and I have referred to a recent effort. The main point that I wanted to stress is that whereas these urban water challenges are inescapable, as researchers and policymakers, we have a certain duty to develop and make available certain instruments that ensure that policy is based on evidence and not sound bites that perhaps the term smart brings. So despite this fascination with the high technologies, I think our objective must be to go to beyond this and to examine the risks, the costs, the benefits of adopting smart water technologies, and given the challenges of water in urban context, I think this is a very worthy effort. And that's all for me. I'd be delighted to answer questions and to clarify things that have not been cleared. Our project is still ongoing, so we are particularly keen to learn from your experience and to see ways in which we can integrate your insight into our research. Thank you very much.
Okay, well, thank you very much, Dr. Quesada, for a very tightly organized and also inspiring presentation. I mean, you have just shared with us the latest thinking, okay, on this topic of smart water cities. Appreciate that very much. Yeah, we can proceed, okay, to the second main presentation. Okay, so let me introduce our second speaker. Our second speaker's name is Mr. Sunpil Jang. Mr. Jang is a smart city expert, and his expertise lies in urban water management. He holds degrees in water management and water infra operation and management. He joined the International Water Resources Association under a secondment from K-Water for the Smart Water City project in February 2021. Now, Mr. Jang is also a senior manager at K-Water, and he is now based at IWRA's executive office in Paris, France. He is currently an officer for the Smart Water City Certificate project. Mr. Jang has extensive hands-on experience in smart city project planning, as well as with water resources research, water operation and management, and river restoration. He has led the Busan Eco-Delta Smart City National Pilot Master Plan project, and he has helped draft the technical note for 4 rivers restoration projects. For today, forum, the topic of Ms. Zhang's presentation is the future of sustainable city, Busan Eco-Delta Smart City. So may I welcome Ms. Zhang? Ms. Zhang, please. Yeah.
Thank you. Thank you, Frederick. Thank you for giving me a chance to introduce the Busan Eco-Delta Smart City. My name is Sunpil Jang. I'm a senior manager of the K-Water. I was in charge of Busan Eco-Delta Smart City project. And also I joined the IWRA and for the Smart Water Certificate program. I'm working with Dr. Monica. I really appreciate to give a chance to introduce the Busan Eco Delta Smart City today. First of all, I would like to introduce our company. KWAR is a state-owned governmental organization for water managing in Korea. We was established in 1967. KWAR is a national leader in providing efficient management of water resources. And we have a diversity business including the water management, renewable energy, and waterfront, such as the smart city. And also we developed water industry in Korea. Today's topic is smart city and smart water. All of us know smart city is becoming global agenda. Nowadays, cities have rapid urbanization and social problems. According to UN report in 2018, as shown in the pictures on the right, the 55% urbanization rate is creating various social problems, such as water shortage, natural disaster, traffic congestion, also fine dust. These are posing as a major threat to the city's sustainability. The issue of those problems from climate changes and urbanization, it makes our cities need innovative changes. Countries around the world are paying attention to smart cities as a new alternative to solve urban problems using fourth industrial revolution technologies such as IoT, big data, and AI. Smart cities are defined in various ways, and each country's approach to smart cities is many different ways. Korea defined the smart city as a platform to improve the quality of life for citizens, enhance the sustainability of cities and new industries by utilizing innovative technologies of the fourth industrial revolution. So Korea government decided to develop national pilot smart city. This is the whole picture of Busan Eco Delta Smart City, which is one of the national pilot project. Busan is second size of city in Korea, located east side of the Korea. The Busan pilot city is the color zone, where rivers pass the three directions. The area, population, and project cost of the pilot city as shown in the table on the right. Here is the concept of Busan Eco Delta Smart City. Is creating a smart city that changes the daily life of citizens through 10 innovative technologies, such as robot, smart water, smart safety, smart healthcare, and more. Especially, we want to focus on the smart water today. We think the smart water city is not only about the IT technology, such as AI technology, data technology, or some sensing is not the only the reason why we have a smart water city, but also smart water city can be a solution for the sustainable city. We just focus on the how to city make a sustainable. This slide already Dr. Monica explained this. I certainly mentioned this. Usually we think we focus on the water supply and water treatment and drainage for the water management in the city. But We think the smart water city should consider waterfront usage, also water cycle restoration. So that's the future of the smart water city. So we want to show the future of smart water city at the Busan Eco Delta City. From the urban design stage, we consider both eco-friendly waterfront design and the restoration of water circulation. The Busan Pilot City designed based on the waterfront using 3 rivers and waterways in the city, and create a culture front where people can experience nature, leisure, and various leisure activities using water. City can be a platform for the water technology. So we plan to create a city specialized in water with cutting-edge water management technology applied. City has urban has many problems, especially urbanization, and also floods and droughts occurs frequent due to the climate change. Also due to the aging water supply pipelines, about 15 of purified water is being lost in Korea. It strengthens the sustainability of cities. This city is adopted the smart water management technology by K-Water's 50-year water management know-how, and is introduced smart water works in the new city for the first time in Korea. In terms of the urban water cycle, this city provides services such as water quality and water quantity of water, as well as drought and flood information. The first is an urban water disaster response system. To create the flood-safe city, we plan to install the high-resolution rainfall radar in the city to predict and analyze local rainfall in real time. Currently, the rainfall monitoring system in Korea is vulnerable to localized sudden heavy rain. Using high-resolution radar-based localized heavy rainfall and flash flood monitoring, prediction, and evaluation technology. We already tested at the Seoul. We built up the high-resolution radar in Seoul city, so we have a good feedback from the Seoul city. And also we built up the water disaster management system for monitoring water management infrastructure such as river level, flood gates, and drainage facilities. And also due to the urbanization, we have some problem of first step of water circulation because the city is covered with concrete. So in the smart city, we naturally structure the city covered with greenery and gardens instead of concrete. And also the water quality in Busan has a problem because the Busan is the mouth of the river, of Nakdong River. So water quality is very bad. So we decided to build up the test bed to improve the river water quality. So we building and operating test bed for optimize the development for local environment from the 2018. The next technology is the smart water management technology. Water supply management using ICT technology in entire process of water supply from the water source, such as rivers and dams, to the house. It is a technology that provides customized services to citizens, such as real-time water quantity and water quality management, as well as in-home plumbing diagnosis. We can save the water from the water leakage, and also we can save the energy. As if we already had a pilot project in Paju City, customer satisfaction has also improved by about 10% or more. This is the most important part in our project because we built the small size, the water treatment facility in city. It's a kind of building type water treatment. Actually, we have some problem. Most water supply system in Korea is centralized. That means in the process of the long distance movement of water supply through the pipeline is exposed to the risk of accidents such as leakage and water pollution. To solve this problem, we built up the small size water treatment near and the customer. We also have a pilot project in Cheongju. And also we are planning to 100% water reuse in the city, using water in the part of the city more than once. Wastewater is reused for cleaning to fill the waterway and to the water to the park. And also we are going to use the hydrothermal energy. From the water river in the city, using the water temperature difference from the water river and also the atmosphere. We using this technology, we can save the energy in the city. This is a case study. We reduce around about 30% the energy using hydrothermal energy system. Busan Eco Delta Smart Village is the first residential complex of the pilot project in Smart City. It's a living lab where people meet the future living and advanced technologies that will be implemented in Busan Eco Delta Smart City. In experimental housing complex, residents can experience the giving and give the feedback on implementing cutting-edge technologies, including all the technology of the water part. Smart Village consists of the total of 56 households and about 200 people, and the various smart city technologies are being demonstrated. The data collection in village will be used in the Busan Eco Delta Smart City whole park. Residents live free of charge for 5 years and participate as a smart city experience group. We call this Living Lab. Residents completed moving in January this year and are currently living there. We expect the benefits, reduce the unnecessary water use and increase the available water usage in the Busan Eco Delta Smart City. From now, I want to share the experience during the planning and building the smart city in Korea. We had 3 major critical issues of a smart city. First of all is personal data collection. As you know, the people don't want their privacy invaded. So most smart city has a problem about the personal data collection. Some people maybe know the Google tried to make a smart city, waterfront smart city, such as the Busan Eco Delta Smart City in Toronto, but they canceled their project because the people doesn't want to invade their privacy data. So we faced the same problem in the Busan Eco Delta Smart City too. So we tried to find out a solution using the test bed. This is the Busan Eco Delta Smart Village, which I already explained. We give the apartment for 5 years for free, and then we contract with the residents to give their personal data. This gonna be the living lab for the personal data collection, because the people we want to know, people want to accept the share their personal data, or they don't want to unaccept their personal data. It's kind of the test in the city. So the residents of the smart village, if they agree that the data sharing to they're agreed, or they want to open data, we are going to expand it to the smart city, for the smart city. But if because no one knows who want to share their data, or which data they don't want to share their data. So we built up the Busan Eco Data Smart Village for the data collection living lab. Second is innovation is always fight with the regulation, but make a new law or change the law takes time and efforts, and very difficult in Korea. So we introduced the regulatory sandbox in Busan Eco Delta Smart City to allow the active application and testing of innovations and the new businesses. Last, the issue is the biggest issue, one of the biggest issues, because the cost of city management is always the kind of homework in the smart city, because municipal government doesn't have any experience and don't want to spend more money in the smart city, because, yeah. So look at this graph. Usually normal city has spent the money, expenses money, but smart city has extra cost for the smart service. But smart service is new technology, so it can make enough money to develop and using the innovate the technology. So we have a gap in the smart city. So we decided to give a chance to develop the real estate month to SPC, which is a special purpose company, to make money to the new innovative technology. So we consist of three parts: is municipal government and the private sector, and also K-Water. We are establishing the SPC, ensures securing the necessary expertise, and also they make money using the developing the real estate month. Thank you for the listening, everyone. I hope if you have any questions, just let me know. I will answer. Thank you.
Okay, thank you very much, Mr. Jang, for a very, how should I put this, very captivating presentation. The presentation is richly illustrated, and there's a lot of live images, and it will help to sketch with the vision of this the Busan Eco Delta Smart City. Yeah, and particularly interesting is that at the end of the presentation, you highlighted the practical challenges in implementing this innovative idea. Okay, I think that demands some more thoughts. Okay, on how to carry out this very ambitious project. Okay, it's the Busan Eco Delta Smart City. Yeah. Now we're going to move on to the next segment of the forum. Okay. Now this forum, we label the forum as interdisciplinary forum. The idea is to merge the two perspectives, engineering and the social sciences. Now, in addition to the two main speakers, we have invited two discussants, okay, to provide a rejoinder each, okay, to the main presentations. The underlying idea is that the forum will bring together perspectives from different parts of the world, okay, and the role of the discussants are to provide their views on the link between the local and the international, and the link between theory and practice. Okay. So we're happy to have two discussants who are going to play that role, okay, to provide our thoughts, okay, on the links between local and international, and between theory and practice. Yeah. So our two discussants are Mr. Kwok Tai Chen and Professor James Nickum. Okay, and they're going to give their rejoinder in that sequence. So let me introduce first our first discussant, Mr. Kwok Tai Chen. Mr. Chen is a team leader on system modeling with the Water Supplies Department of the Hong Kong Special Administrative Region Government. Okay, so Mr. Chen, please.
Yes, thank you, Frederick. Thanks to Monica and Sung Pil in providing the landscape of smart water cities from a global perspective, and also the Korean experience. Of course, thanks to the Hong Kong Youth Center for Water Technology and Policy in organizing this very interesting and also useful forum. Now, let's share our experience in implementing smart water in Hong Kong. Smart water, go smart, go digital, to us is a must. And this is also the direction of the Water Supplies Department, Hong Kong SL government. Now, among all the advanced water utilities, I would say, all the water companies in the advanced economy, that we consider Hong Kong is one of them, the common consensus is that digital transformation is a must. Now, sticking to current existing practice is comfortable, is in the comfort zone, that we must move on, because the old and obsolete technology simply can't survive, and we will definitely be left behind. It's not a matter whether go or not go, rather a matter of the pace and coverage, the timing and phasing. So we are committed to go smart, go digital, and to undergo the digital transformation. When we talk about digital water or digital water solutions, it is quite thorough, I would say, because it's present in the whole water cycle from source to take, from collection, transfer to treatment. Smart or digital really means using data to make smart decisions. It means more cost-effective, better water quality, less energy consumption, less wastage in facing the challenges upon climate change, urbanization, and under extreme weather. Now, how can we achieve that? Okay, in simple terms, we have to use the latest advanced technology that are quite a lot, include the ICT, information communication technology, the machine learning that the two speakers has mentioned about, data analytics, cloud computing, augmented reality, AI, digital twins, the IoT sensors, real-time computing, real-time control. So among all this, I mean, applying all this to all the areas, the operation areas, we will focus on two particular areas that we can apply most. One is smart installation. The other is smart network. Smart installations include the water treatment works and also the pumping station. We have smart dosing. That means we dose the optimum amount. That can save a lot, not just the money, because all the chemical we use will ultimately go into the water cycle. That means we also save the money, save the energy to treat these chemicals. And also, in this smart installation, we are also aiming at unmanned operation, unmanned installations, pump scheduling, so as to save energy. And also that unmanned operation will mean we have to have the alarm, the alert systems that are smart to tell us the real issues. They will alert us when there's a real issue come up. Now, the other is the smart supply and distribution network. As I've been working on the network operation and planning for quite some time, we'll go into that in the little bit details now. So what is digital water to us? It's from the International Water Association and also the Smart Water Network Forum, the IWA and SWARM, that promote both digital or smart water, talking about digital transformation, how to move from the data silos to a data lake. Now, in order to have some ideas of what is all these smart water things, I think there are three key elements or three key processes that is easy to remember, and also that talk about the gist of things we are talking about, as long as the sense, predict, and act. What is sense, predict, and act? Sense means we collect data. In order to be smart, we make smart decisions based on data. So the first thing is how to collect. Through the IoT sensors, through real-time transmission. And actually, the real challenge here is that we are getting more data. We are getting more data available. But it also comes with the issue of data cleansing, data quality, data compatibility, and data completeness. Now, all this when we go into, because I've been working in the industry, so it's the problem that we have been facing every day. So the second part is the predict. After we sense and collect things, we have to predict. And this comes to those analytic technology that we mentioned all this time, the cloud computing, AI. It's all about how to use this data, how to use the machine learning, how to predict what will happen next. So is the second part. So the last part after we sense, predict, is to act. Is the smart decision making, the real-time control, how to visualize it, how to do the simulation. So actually, this sense, predict, I personally quite like it, because it's not only applies in smart water. All the smart things, when we talk about smart cities, smart transport, it's all about this sense, predict, and act. So when we think about how to use, how to apply the latest technology in this, we can put into this framework. Okay, then we go into the groundwork, how we build the hydraulic model or the digital, or we upgrade or we move it to digital twin after we build. Now, you see, this is the whole process, the model database with all the input, and then how we use it, how we calibrate it, how we apply it, how we do the analysis, and do the simulations and do all the things we want. So it's quite an involved process that one can't imagine how to accomplish without the latest technology that we just mentioned. Indeed, when I look back, when I start my career back in late 80s, without the tools that are already available now, what I can do or what we can do at those days is just have a very rough idea of the network performance, because we have to approximate things. We don't have enough data. And what we can have is a really oversimplified picture of the supply system. So we got the golden opportunity to gather the data that we can make use of. Yeah. So come to so it's how to distinguish between the traditional hydraulic model and the digital twin when we talk about twins, we must have two parts or two as a twin. One is in the physical world, no matter it's the installation or the water main buried underground. The other is the computer system, the model that work in your office in the computer. How to link these two twins together? If it's not linked, then we can't call it as a digital twin. It's linked by those real-time IoT sensors. That means the IoT sensor, those Internet things, the sensors collect the data, could be pressure, could be water quality parameters, could be flow, could be temperature, all kinds of things, and feedback to the system and to modify our model of give it the real-time data so that we can know what is actually happening, in the real world. So when we have a model well calibrated, do we own the crystal ball? I will say, you've got a model, it's well calibrated, so it's got your digital twin. So it's not yet quite far away from the end of the story, because the real challenge is that we have two parts. One part is the infrastructure, all those water mains things. The other part is the demand. We are the water supply company. We supply water, but we cannot control, we do not and cannot control the water each customer is going to take. That means the demand is not something we know. It's something we have to use the data technology to predict. Just like marketing. You can't control your customer to buy which product. They decide themselves. The best we can do is to use the technology to predict and got good predictions. If we can got good prediction, then we win, or so it's all these challenges that we have to overcome. Not just Hong Kong water supplies, but all the water supply companies are facing. So that means we still have a long way to go. It's not yet got the crystal ball. So just a glimpse of what we have done. We have over 200 freshwater supply system in more than 40 model clusters. We have freshwater, flushing water. We have the raw water and also the trunk transfer system that costs us hundreds of $millions of electricity bill each year. I think there will be much more in the Western countries because of the unit cost in the dollar per kilowatt hour is much higher than that in Hong Kong. So you can see it as a real challenge and also real opportunities by using this smart water technology or smart technology that can reduce the bill. Reducing the bill, not just saving the money, but also save the environment. So to sum up, this is the smart water application, the way that we aim at. First is to can have an impact assessment under different scenario. There's a scenario management under the emergency planned works or new development, and also to optimize operation by knowing how and when to deliver water to decide supply zones. How can we have a when? Because over the 24 hours, you don't deliver the same amount of water. So it's not just delivering the right amount, but we want to deliver it so as to has a minimum cost, minimum energy bill, still yet satisfy the need of the customers. And the last is the most challenging one that I think most water companies are still looking at how to use the smart waterways to reduce the need, the water leakage. Yeah, that's all I want to share with the water community, the water supply community, or about the things we're doing in Hong Kong. Thank you.
Well, thank you very much, Patrick. Yeah, Mr. Chan. Okay, I call him Patrick. Yeah, thank you very much, Patrick. Yeah, I mean your observations, okay, are grounded. I think that's variable, okay, for a lot of the listeners, okay, to this forum. It's grounded in facts, okay, that are not available in a public domain, okay. So I think you've done a very good job in terms of like making this connection as a practitioner, right? You make a connection between practice and what's being put forward as like a theory of the application of smart technologies to the to managing urban water resources system. At the same time, you can also point out, okay, there are peculiar conditions in the local system, okay, that we have to be taken into consideration, okay, in thinking about the application of smart technologies to make it work better, more efficient. Yeah, so I think this is what I think is the most interesting observations that you have made. Yeah, so thank you very much, Patrick. Yeah, I'd like to invite our second discussant to share with us, okay, his thoughts on the two main presentations. Our second discussant is Professor James Nickum. And I said earlier, this whole thing on smart water city, this forum is his brainchild. Okay, he's like, hey, I mean, I talk to Jim, okay, on almost on a weekly basis, because in his capacity as one of these three international advisors to the Water Center. And so you are in a perfect position, okay, to give us your thoughts, okay, on how the local and international so I converge, okay, on this topic, smart water city. So Professor Nickum, please.
Well, thank you very much. I'm unmuted now, right? Thank you very much, Professor Lee. And I think you've set out a big task for me. I don't know if I'll be able to handle it, especially after these three excellent presentations that I'm asked to follow. I'd like to thank the Center for asking me to join this, and I hope that my suggestion of this project is one that stimulates some conversation and that we can see some applications to the situation in Hong Kong, which, as Monica pointed out, is one of the case studies that we use. I mentioned this not just because of that, but it's also because, as you've mentioned, I am a member of the International Water Resources Association, and this is a project that we are engaged in with K-Water, which is one of the lead agencies, I think, in the world in terms of developing, thinking about smart water cities, and in many ways using it proactively to develop technologies and the like. So what I would like to use as my framework here is to note that this is not our first collaboration on smart water with K-Water, between IWRA and K-Water. We also collected some case studies just on smart water management a few years ago, and published a report, a number of different cases, not always cities, which is interesting. And then, as may have been mentioned, I am, let me get this going, I am the editor-in-chief of Water International, which is the official journal of IWRA, and we did a special issue where we took some of those case studies, but then we expanded and solicited other ideas, which we were a little bit kind of in your face here with the title, but is it smart water management? Is it really smart, or is it just another pretty name? Because I think there is a long-standing skepticism about going to technical solutions. They are fine, but there often are some tendencies to overlook some of the problems that are limitations. I must say that in both of the presentations of Monica and Sung-pil, there was much more addressing of this, so much of this may be outdated. But let me run through some of these things. One of the things we did was that we solicited openly of IWRA members to tell us, do you think smart water management is really smart? And we get about 7 answers, not too many, and there were 3 of them are kind of worth mentioning here. And I think basically the attitudes were positive, that it would, the technology, obviously, I think as Patrick just pointed out, they have obvious applications. But with smart water management, will it answer core questions about priorities and values? One of those is the codependence of ecosystems on water supplies. Again, in the Hong Kong case, I was interested to see that reducing the electricity supply and the water intake might have some positive effect on the ecosystems. But there's still a question: are there larger values there? I think again, in the case of raised by Sung-pil, there was an attempt to look at many of those larger values. Smart water management may not be too applicable beyond developed country cities. Now here we've seen the attempt by Monica and her team and the case studies to look beyond developed country cities. And we find they look different. Their problems are different, their capabilities are different, but there may be some aspects of new technologies that can help them overcome their problems. And another one is sort of like, well, that's another good idea, but the key, as always, is how to implement it. So that's what our experts told us. Now, it's a rather large special issue. And so at the end of it, we had a kind of a summary of an editor's checklist of what we know about smart water management as of 2 or 3 years ago, what its promises are, what its limitations are, and what needs to be done. Its promises are that it will help improve access and affordability of drinking water, among other things. I mean, I think it's been pointed out here that drinking water is only one aspect of the whole urban water cycle. But that's a very critical aspect. If people don't have drinking water, they don't have the access, and it's not affordable, that's a problem. It may improve the flexibility, efficiency, and reliability of water systems. It can increase the knowledge and decision-making opportunities through the ability to diagnose, inspect, and repair problems in water infrastructure when they arise. Again, this is, I think, the case of Hong Kong, I think, elaborated on how this is possible. Can improve data quality, again, Hong Kong, access, consistency, transparency, and frequency of observation. All of these are good in general. More promises: manage and reduce financial risk, or improve the financial position of water utilities by reducing infrastructure costs, improve capacity, and reduced water loss. I think that's kind of an open question in many cases. I'm not sure, because of the high cost of many of these technologies, it's not entirely clear that they improve the financial position of the water utilities. And there, I think the Busan Eco-Delta City issues that were raised at the very end kind of bring this to the fore, and I think some of the case studies that Monica looked at. Improve the quality of service provided by water utilities, including increased trust in water suppliers through transparency. Well, again, that actually turns out to be maybe a problem, as again, the Busan case is, and the Toronto case as well. If people think that you're gathering too much personal information, that does not increase trust. So it adds to the burden of water suppliers to ensure the transparency. I actually had a conversation with someone who is a water manager in Paris, and he was talking about how wonderful all this kind of integrated databases will be, because we can take electricity use and water use and so on and so forth, and we can know how many people are in somebody's apartment at what time and what they're doing. Well, that almost like that, we'll have so much information. And I'm thinking, I don't think the French are going to go for that. Okay, so it also provides the opportunity to test, develop, and leapfrog over past water system challenges. And we hope that is true. But the promises can be dashed by the technology actually being used to patch up a broken or outdated system, rather than to address some of the more fundamental institution or management problems. I think there we had an interesting paper on Ottawa, which has an antiquated water delivery system, and adding technology to it isn't likely to do much for it unless you somehow repair the system or redo it. There are situations like the new cities start from a good position. The old cities, like I think New York is one of the case studies, and that have the old facilities, and may have some issues in that. Being adopted without the critical thinking needed to avoid major risks. It's always easy to, for example, get the budgets for the new technologies, or get the staffing and so on and so forth. Then you really think, well, is this heading in the right direction? And you won't know until it happens. Ignoring more interesting or more promising alternative narratives and options, and locking society into the false thinking that technology will serve all water problems. Again, that's a common criticism. Take it or leave it. If you believe in the technologies and think that they, in the end, are better, but there are those critics. Not recognizing that posited long-term benefits are posited. They're speculated. Things never turn out as projected, pretty much. I mean, that's almost a general rule. Security and privacy concerns, we talked about that. And another one is making a big commitment for a specific technology when technology is advancing rapidly. Again, I think the Busan example, the K-Waters, is very impressive how they think through these things. Was also saying the revision that you need to work out a way to fund the next technology, because it's going to happen. And, 5G is going to be followed by 6G, for example. What needs to be done? Well, you think critically of alternative narratives. And these are always kind of hard to think through, because you don't know what can go wrong, but you need to try to think, because what could go wrong probably will. How resilient are the waterfront cases, for example, in the face of major typhoons? I think that's maybe there will be. That would be great. Can the waterfront development that is being developed for the Busan eco-city, can that be applied somehow to Hong Kong, for example? I think this is very interesting that K-Water brings under its umbrella water sewerage, renewable electricity, waterfront development, and actually urban development. That's really quite a combination of skills. And it gives them some unique capacity to actually try to do some of these initiatives. But can anybody else do it? Where did I go? Have we reassessed what our water systems should look like instead of fixing broken systems? I think that's an old complement. Technical smart water manager with innovative institutional managers. That was a big takeaway from Monica. I think that in trying to develop a better index, you've got to think about governance, you've got to think about institutions. We actually had one attempt to say, well, smart water technology needs to be complemented by smart water institutions. I think there's a lot of truth in that. You also need to think outside the silos of fragmented management, where you're looking at, I think, the idea of the urban water cycle. Well, the urban water cycle in many cases is still fragmented among different agencies and different authorities even that oversee those agencies. So you need to somehow consider the full hydrological cycle. I noticed that even in the case of the administrative problems that were raised by Sung-pil in terms of the problem of authorization and so on, it still went to one integrated ministry, IMLIT, to get the permissions. So at least there's kind of an integrated ministry working with an integrated company. And I thought that was interesting. Okay. Oh, those are long lists, and I probably exhausted my 10 minutes more than long ago. I've made most of my points here, but I think I certainly applaud and endorse Monica's conclusion that what we know now shows that we need more. We need a framework. We need a way of figuring out, what do we mean by smart water cities? How do we produce guidelines or a framework that can work in Korea, in Hong Kong, but also in Ciudad Juarez, or actually Nakuru is a very interesting one because that's landlocked, and I was wondering how that works, but and it's not very rich. It has wonderful flamingos, I think. So how do we get something that can apply to a small East African city like Nakuru and New York? That's a tough assignment, but I'm sure that Monica and the IWRE team, K-Water, are going to get that settled and come back next year. Sung-pil has shown us an ambitious effort to address many issues in one of the leading countries in developing these smart water approaches. I think an interesting point that I came out of this was that the view to developing that a smart city will help to drive the innovation itself. It's not a matter of taking technologies off the shelf. It's using the developments to create new technologies and to test them. And that, I think, is a strong point. But many questions remain, as he noted. Last year, I had the great honor of visiting the Eco Delta city before anybody moved in, and it was interesting. I wonder, it'll be interesting to see how efforts like this evolve, whether they can be expanded, and whether their lessons can apply to situations elsewhere. If I have one small question is, again, to think, how can we think outside the box on all this, especially, and this is really amazing. And one thing I wonder is, in the case of Korea, I think the presentation started by noting that urbanization is growing rapidly in the world. It's not in Korea. And in fact, the population is collapsing. I mean, to put it politely. Are these smart villages going to be attractive? Will they hold people after they get their 5 years of free rent? I don't know. Maybe we have to come back in 5 years. But anyway, these are really some great and I think very thought-provoking presentations. Thank you very much.
Well, thank you very much, Professor Nickum. Jim, yeah, as usual, you have raised a lot of like thought-provoking questions, okay, in your remarks. I mean, this is what we need, okay, to help us like think about the questions that we should be asking. So I appreciate your sharing, okay. Now, we have received a total of 7 questions from the audience, yeah, and I was just reminded, okay, by my colleague. By the way, Dr. Ada Chan, she's the one organizing this event. Okay, thank you very much, Ada. Yeah. Now, she just reminded me that we should really make best use of the time that we have, okay, for this 30-minute Q&A session. I thought we'll go, okay, according to the order of the presentation, meaning we would go with like Monica answering one question and not taking more than 3 minutes to answer the question. Okay, and then we move on to Sampil, answer the second question, and then Patrick, and then Jim. Okay, so Monica, let me sort of like say the question for you. Yeah, I have to make a choice. We have more than one question for you. Okay, and I pick a question that looks at the intersection between smart water technologies and the digital divide. Okay, so the question is this. Okay. Smart water technologies are supposed to help improve the quality of life of all citizens. But now there's a digital divide, okay? So the question is, like, is there a solution, okay, addressing digital divide so that the less tech-savvy population or the underprivileged population could also enjoy the benefits of smart water technologies?
Yeah, thanks. This is a very good question, and it is not reduced, obviously, to the water sector, but we are seeing that digital divide in many other sectors. Yes, this is something that we have to factor in when we look at smart water cities. I would say that there is no silver bullet for as a solution, but I do think that from the example that we saw last year, the solution may involve certain practices such as consultations, procedures, and given the users and the consumers the possibility of feeding back to the authorities to tell them about what works and what doesn't. And it has to necessarily involve not only the people that can use the technologies, but certainly those that have difficulties. This is not exclusive of the water system, and I think it's a challenge that cities and other policy areas are facing. I do think that feeding back and consulting the users is definitely necessary.
Okay, thank you very much, Monica. Sampil, I have a question for you. It pertains to one of the 3 challenges or critical issues that you referred to in your presentation, and that to do with privacy. Okay, so the question is this: providing rent-free housing doesn't seem to be a scalable solution to addressing people's concern about losing their privacy. Okay, so can you explain why people do not want to share data and what could be done to address people's concerns about privacy? Yes, some people, please. You have to unmute yourself, some people, yeah. You have to unmute yourself, yeah. Okay, thanks.
Yeah, that's very interesting question because that's also big the challenge for us. So actually, people don't want to share their healthcare data or their where they go, what they eat. They don't want to their privacy and share their privacy. But people don't know which kind of data share in the smart city. Personally, so we want to find out which kind of data can share, which kind of data is going to be valuable in the smart city from the residents. So actually, smart village is the kind of living lab. Just we want to figure out which data can open, which data cannot open in the smart city. People, we want to let the residents know which kind of data we will collect or which kind of data we will not gonna collect. So this is a kind of test bed. Yeah.
Oh, okay. Well, thank you, Sampio. Yeah. Patrick, yes, so okay, it's a question. It's challenging, okay? I mean, the audience have been asking challenging questions, okay, this round, yeah. So Patrick, there's a question about the application, okay, of smart technology to address some local problems. And that local problem is leakage. So here's the question, okay? The question is, could you share, okay, one or two near-term projects or initiatives of the Hong Kong model in regard to addressing the question of leakage, given that we are still, Hong Kong, okay, is still losing about 25% to 30% of the water in a distribution network. So could you tell us what the initiatives currently being taken to address this problem?
For the water leakage or in the government distribution network, we have over the last 10 to 15 years about the replacement and rehabilitation program. We have drastically moved that figure from 25% to 15%. So we are in a next phase that we target to reduce this 15% to below 10% in 10 years' time. Under we call the WIN project, we keep on replacing those water mains that are most susceptible to leakage. We implement the DMA, the district metering areas. We are still in the process. We divide up the whole Hong Kong into more than 2,000 DMA and PMAs. And then we prioritize those that got high in the list in terms of leakage. And we are still working on that project to reduce that leakage to below 10. It should be year 2030. Is it 2030 or 20? By 2030, that means still 8 years to come. We target to keep that to below 10%.
Oh, well, thank you very much, Patrick. Yeah, Jim. Here's a question that maybe I think is appropriate. Okay, appropriate given the scope, okay, and the orientation of the question that you be the one to address that question. Let me read the question. Okay? Can smart city thinking be applied to rural or less populated areas? And how can this thinking be applied to regions that have a lot of water, like the Great Lake region in the United States Canadian border region? Yeah.
Well, technology is technology. in the sense that the newer technologies presumably have some applications, but there is, I think, that question, and to some extent it's valid, about how much, at least smart water management, smart water city kind of approach can be used in rural areas. Now, especially in poorer countries. I think if you're talking about someplace like the United States, I think they're already using smart technologies to determine very precise irrigation schedules and to use satellite kinds of monitoring and so on. But that's large farming. That's large budget farming. The critical problems: what do you do about people or areas that don't have a lot of money and may not have a technical capacity? And that I think that's just like the digital divide. There's also an economic divide, and I'm not sure that all of this smart technology is going to help. As far as the Great Lakes region, they're probably already using some advanced technologies in monitoring and coordinating. I would be surprised if they weren't, at least the Great Lakes Commission and so on. If they're not, then I think that's a choice.
Okay, well, thank you very much, Jim. Yeah, I think we have time for a second round of like questions and answers. Yeah, so let's go back to Monica. Yeah, let me see. Here's a question. It seems a bit. Let me read the question. Okay, it sounds straightforward, but you may not. Okay, who should be the one planning the smart water city initiatives? Can water utilities alone come up with a comprehensive plan for a smart water city? My guess is that this question asks a question of like, who are the key stakeholders, right? Who should take the lead, okay, in terms of like planning a smart water city initiative? So
yes, I can refer again to the cases that were examined in last year's report, and what we saw was that even in the more piecemeal, incremental approach to smart water cities, small projects, all these small projects involved a series of actors. It was never one single water utility undertaking the work required. It was obviously the water utility, but it was a common effort with the municipality, very frequently also with the regional or even the national governments. And it also involved citizens associations. It was never a single actor effort. It involved, even in very small, very limited projects, it involved a series of factors. So each of them bring to the fore their capabilities and their expertise, and definitely the smart utility, the water utilities play a role, but by no means they are the sole actor, I would say. That's what the evidence from the case studies show.
Okay, thank you, Monica. I think some people can add to this.
Yeah,
please. Yeah.
Yes, I think it's actually depending on the country, different organization plan the smart water city. Especially in Korea case, the government and the K-Water is the lead the smart water city initiative and policies in Korea. And also I saw that other question about can water utilize alone come up with the comprehensive plan for the smart water city. May I answer this, Frederick?
Yes.
Yes. We recommend, actually, we also, Korea also just focus on the smart water for the smart water supply, water utilities. But now we recommend we consider the urban water cycle, whole water cycle, because everything is connected. For example, if we use the water supply using the water in the house, and we need a sewage, and also water quality of water source is very important for the water treatment. So now we recommend we consider whole part of urban water cycle for the smart water city.
Okay, thank you. Maybe, I think I can also invite you, whether Patrick or Jim will have anything to add to this answers to this question about who should be taking the lead. Yeah, I mean, in some stakeholder, the water utility, the government, water utility, like a public economy. Yeah, Jim. Yeah.
Well, I think it's smart water city. It's not. It is the whole city, and I think one of the points that we're increasingly realize is, I think it was in Sung Peel's presentation, is the nexus. And actually, it was also in Patrick's presentation, that water is connected to energy, in particular, and it's and a smart city is another level. A smart water city has to be embedded within a smart city, which includes transportation networks, communication, and things like that. So clearly, I think the ultimate responsible authority in a city is the municipal government.
Yeah, Patrick, would like to add to that discussion about
I think to us the water supplies department will, I think those areas is under our scope. We will definitely move, just like optimize our operation, and also from the, as I have just presented, the whole water cycle from collection to the water take. We try to seize all opportunities to apply these water technologies. But what I have focused on is the smart installation and all those smart network. For the other part, like serving the customers, we also have our plan, but that's not the main part of my presentation. That means to us, what the government or the Hong Kong SAR WSD can do, we will definitely do. Yeah.
Okay. Yeah. Thank you, Patrick. Yeah. On that, maybe I can, Patrick. I mean, let me ask you another question. Yeah. This is something so like more forward-looking, and also at the city scale. And that question pertains to the intersection between the smart water technologies and climate change. Someone asked a question about how smart water technologies could be applied to address the question of water scarcity. Okay, the assumption is that water scarcity is the reason why, or water scarcity problems, have led to the development of smart water technologies or smart water city concept. Okay, and then with this increasing concern about climate change induced uncertainties. And I'm reading from the question. Okay, the glaciers are melting, so is there an opportunity, to make use of smart technologies to produce more like water resources to address the problem of water scarcity? So basically, now this is how the question was phrased, right? But Patrick, I would say, within the context of Hong Kong, to what extent and how smart water technologies have been applied or will be applied, or incorporated in the overall management framework in Hong Kong, the urban water management system, to address the concerns about climate change induced uncertainties.
maybe this, I mean this area, how to apply the smart water technology onto the water resources is not an area that I'm quite familiar with, that I can't provide much input at this moment, at this juncture, That means how to use the smart technology to get more water resources. And I think at least those applications that we are doing, that we are working on, like the leak detection, reducing leak is another way of less wastage is also another way of getting more water resources. That's an area that we have been actively working on. For example, by building the model. With the advance of the technology, maybe one day we can have more sensitive pressure loggers that can tell us very vividly from the reservoir to the whole network where the water has been passing, I mean the flow. If that amount of flow is not consumed by the consumer, then it must be a leakage. Of course, for example, the smart technology in, say, for example, back to late 80s, we don't have that kind of pressure sensor that can sense the high frequency. It's another area that the academics are working on. With high frequency, we can detect more than just the static pressure. That means the transient pressure. There's many areas that are still under sort of development, that people are still, I mean the university academics, the laboratories are still working on, so as to so I think that tomorrow is in a way is very bright in terms of the advancement of technology, that we can have a quicker feedback of the data and the computer that run faster, maybe through cloud computing, that kind of things, that we can have more meaningful things come out from the data.
Patrick, I think you're being modest. Definitely what you've been doing, okay, you have already shared with us, okay, the work that you've been doing at the Water Supply Department to address some of the challenges, okay, that Hong Kong is confronted with, such as leakage, okay. So I think it's a matter of semantics. I think that the kind of work that you're doing in regard to the application, for example, okay, this like digital twin, okay, is definitely one example of a smart technology being used to understand the problem leakage and then address the problem leakage. And that in itself is already an answer to the question of, well, climate change induced uncertainties pertain to, for example, okay, this change in rainfall pattern, right? We may have more rain, we may have less rain, okay? But managing demand, okay, through the use of technology to collect data, okay? And I think you've done a pretty good job in terms of describing how your work, okay, making use of data, okay, the informed policy. I think that's what you've been doing is actually exactly the whole focus, okay, of this forum. And that is what the application of like IoT or machine learning or digital technology, right, to managing the water resources system at the urban scale. So I think you're being modest, okay? This is exactly what you've been doing, okay? So thank you very much, Patrick. Jim, maybe you can handle one last question. Let me see, I'm going through the list of questions. This question about, let me see. Something to do with, where is it? You have already answered the question about the application of smart water thinking to a rural area and less populated centers. Let me see. You know what? I'm going through all the questions. It seems like we have already addressed all the questions.
There was one that I wanted to make a comment on. That was,
please, Jim.
That was one that was linking smart water management to water scarcity. And I don't think that's necessarily true. And in particular in the and also that climate change automatically means more water scarcity. It doesn't. The climate models indicate that many places in the world are likely to get more water, not necessarily the way they like it,
Mhm.
but they're likely to get more water. Hong Kong is one of those.
Mhm.
And the trend in large cities, world cities, in recent decades has been for water use to go down. And that's almost worldwide in the developed country.
Mm.
So,
Yeah.
I don't think that smart water management itself is about water scarcity. It's about better delivery.
Okay, that's a good point. Yeah, thank you very much, Jim. Yeah, for reminding us of that. I think that's a very important point. Yeah, we're 2 minutes to 6 o'clock, so we are going to conclude. Okay, the forum on time. So let me take this opportunity to thank our two main speakers, Dr. Monica Quesada and Mr. Sanpil Jang, for sharing with us your expertise on the topic. I'd like to thank our two discussants, Mr. Patrick Chan and Professor James Nickum, okay, for sharing with us, okay, your views, okay, on how to make a connection between the local and international and between theory and practice, okay. I also like to thank all the attendees. We have over 80 attendees, registrants, okay, who have listened. We spent the last 2 hours, okay, listening to our discussion, exchange, presentations. Okay, so thank you very much for spending the 2 hours with us. Okay, so I look forward to seeing all of you. Okay, in future occasions. Okay, so I'm going to bring this to an end. Okay, thank you very much.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.